morning, everyone. Thank you. Today, I'll talk about oriented antibody immunization via random covalent binding, improving reproducibility for label-free electrochemical immunosensing for multi-allergens on silicon chips. My name is Somayyeh Bozorgzadeh. I'm working with Professor Alan Orienden in Tyndall National Institute in Ireland, where is a European leading research center in Ireland, a research flagship of University College Cork, and it has a silicon microfabrication facility. So the main research in the Tyndall has research centers. They have activity regarding to application of silicon in this in different area. Our group, our mission in environmental sensing and energy is to develop electrochemical and chemical sensor for sustainable agriculture, food, and environmental monitoring. Today, I'm presenting a sensor for the multi-allergens detection, but the question is that why we need detection for food allergen detections. Nowadays, food allergens has become important problem, health problem for many people's. Approximately 5 to 10% people, they suffer from allergic reaction as a result of food consumptions. So usually these people should never take those foods for a long time or for the whole life. So they, on the other hand, in industry, food manufacturers, usually they use a same production line for the producing food and processed food. So it means that the cross-contamination can happen, and this is a big issue for the food industry. European Union has identified 14 major allergens to be labeled in any products, and this is also is a concern for authority as well. So these three target stakeholder, we can call it, are interested to have they require actually accurate sensing device for real-time monitoring. But the problem is that the current method for the quantitative measurement is based on the lab-based detection, which needs which costly and time-consuming. Mostly, it require a bulky equipment and also high operator training, and also it's not real-time, so can help the industry to have a right time. Make a decision. So we need a sensor or point of care or point of use device can provide of a rapid, easy to use, portable, real-time, and cost-effective detection. Here in this work, we use a label-free electrochemical immunosensing device based on the electrochemical detection. Our sensing platform is using the silicon microchip for multiplex, detection of two allergens. The two target allergens is the milk and egg allergens. And as it's a very compact and miniaturized sensing platform, it allows us to have a portable, to develop a portable device for on-site monitoring. The key element for developing immunosensor is the antibody as a biorecognition layer. When we develop immunosensor, the attachment of the antibody to the surface is very critical. And as you can see on the left, the antibody structure is made of amino acid full of different functional groups. So it means that the antibody can attach from everywhere. So it happens and it leads to normal, attachment to the surface. And the structure of the antibody is a Y-shaped molecule. Two arms is the binding site, and the tail is the crystallizable region, and this site is not involved in the binding. But when we have a random immunization, two arms can bind to the surface. It means that they are not free for the attachment or free for the detection. So if we can be able to attach the antibody from the tail, it means that we can increase the reproducibility and sensitivity. So how? Different strategy we can use for the random orientation, just physical absorption, entrapment, electrostatic interaction, or random covalent binding are the most usable method, especially for big electrodes, big sensors. But for the oriented immunization, we need some factors to attach just the FC region. So some methods like using protein AG, which is a glycoprotein, it has some binding site, just can attach to the FC region of the antibody, or using the boric acid, which can attach to the sugar moiety located into the FC region, or using the thiocoupling. These are the most popular methods for the oriented immunization. So how we developed our sensor, this is the multi-sensing platform we use. It's a silicon chip. Alan already on Monday, he presented different silicon chip for the lactate and glucose biosensors. We have different design in our group. So this is a single band electrode. You can see here the chip, and there is 3 working electrodes. 3 working means 3 sensors we have on chip. The fabrication is a microfabrication technology through the photolithography, lift-off, and passivation method. And for the developing the sensor, we deposited the gold nanoparticles. After that, chitosan deposition happens electrochemically, and a thin layer of the chitosan was deposited for further attachment. 2 minutes. We followed 2 procedures, random and boric acid. So here you can see the randomization strategy. And the result was that also we could get a calibration for casein as indicator for milk allergens. But when we look at the chip variation, between chip variation, we had an irreproducibility problem. So we went through the boric acid assisted immunization, which helped us to have an attachment through the FC region. Then to make sure that it happens, we have the boric acid functionality. We characterize with fluorescence imaging. As you can see here, the A showed that the chitosan modified with boric acid showed a very good and significant fluorescence signals. And also we applied the anti-IgG conjugated with dye, showed also the attachment of the antibody very uniformly at the surface. After this characterization, we try to extract the analytical features of the casing, and you can see here the differential pulse voltammetry by increasing the concentration of the casing, the current drops, and on the right also you can see the calibration graph for two individual calibration sets, and it's overlaid very perfectly. It shows that how reproducible is the sensor setup. Also, we try to optimize the blocking agents with different, and we found that by using the super block ETA 6%, sensitivity and also detection limit can enhance. Also, the possibility of the EIS determination for this also we explored, and we found that, yeah, by increasing the concentration of the casing, charge transfer resistance also increase and is correlated to the concentration of casing. After that, also you can see here at the top on-chip reproducibility and between-chip reproducibility, and it shows that the huge significant enhancement in terms of reproducibility and reliability of the sensing platform. Then, because the boric acid can attach to any IgG isotope of antibody, so we try to apply for the ovalbumin as an egg allergens, and it shows perfectly for the ovalbumin, and also we try to detect casing in the presence of ovalbumin, and to calibration shows that interference detection of casing in the presence of ovalbumin can happen. In conclusion, with this sensor, we could be able to develop a compact multi-sensing platform for two allergens. Boric acid showed sensitive, reproducible detection for casing, and we could expand the platform or adapt the platform for other antibody. Our future plans also is that integrate this platform for portable electronics to have an on-site monitoring as well, and expand this platform for other allergens. Thank you.